abstract data types. There are a lot of data types that are abstract. Abstract means something you cannot actually visualize, isn't it? Okay, good. Then data types is different from integers, strings, or whatever. The abstract data types are queue, stack, linked list, and binary tree. So these are the abstract data types we are going to discuss in this class. There are two forms of queue or types. We have the linear queue and the circular queue. Okay, so for this class, we will start with the linear queue. The linear queue. The concept of a queue is very simple. Everyone knows what a queue is. Okay, if you look at maybe your dining area where you guys are served food, students are on queue to what? To get their food parcels, isn't it? So you say the students are on queue, isn't it? Why do you say they are on queue? They are on queue because it is the first guy who arrived first that will be attended to first, isn't it? And this guy leaves first, isn't it? When it comes to the turn of the second guy is now the first guy. When he's attended to, he leaves. The third guy is now the first guy. Is that understood? When he's attended to, he leaves. This last guy is now the first guy. When he's attended to, he leaves. That is the concept of a queue. So indirectly, we say it is first in, first out. What do I call it? First in, first out. A queue is a concept, and this is usually applied in a memory location. This is applicable in your day-to-day activities. One, like I said, you guys queue in a dining hall to receive food parcels, right? So the first person that comes will be attended to first, the person leaves, and the next person becomes the first person. And another example is when you send your work to your printer. If you want to print 10 files, you send the 10 of them to your printer, isn't it? When you get to your printer and print, which one do you think prints first? The first one you have sent. That is also an application of a queue. Is that understood? That is a queue. So we have so many applications of a queue in computer terms and in our day-to-day activities. Okay? Now, let's now work with a memory location. Can we see the memory location, guys? No, we can't. But let me draw a memory location to visualize the queue operation. When I visualize the queue operation, then I ask you guys to write a code to implement that queue operation. How can it be visualized? Very simple. Now, let me draw a memory location. This is a memory location. Don't forget that all memories have maximum capacity, isn't it? So if you look at this memory location, what is the maximum space or maximum capacity of this guy? This is 1, 2, 3, 4, 5, 6, 7. Is that understood? So the maximum space is what? Is 7. Are you all following me? Now we want to add items to this memory location, and we want to implement a queue operation. And what is a queue operation? A queue operation means the first file that comes in is what? Leaves first. Is that understood? So that's why it's called what? First in, first out. Is this understood? Good. So the maximum location or the maximum space in this memory is what? Is 7. So let's now want to add some elements to this memory location. Okay. Let's assume we want to add 5, 25, 0, minus 1, 3, 5, 7, 11, 2, 3, 5, 7, 6. These are the items we want to add. First thing I want to ask you guys, can we add everything to this? No, we can't. So what is the first thing? The first thing is to add the first element, right? You guys can see this, right? Is this what is the first thing you have to do before you add this? Check if it is full. You don't have a business with it if it is empty. You only have a business with it if it is full. Or yeah, because if it is full, you cannot add. If it is empty, you can add. And your aim is to add. So you don't have to check if it is empty. What you need to do is to check if it is full. Is that understood? So what is the first thing to do? Check if this is full. Is this full, guys? What do? We add 5. We add 5. Now 5 has been added, isn't it? What is the next thing to be added?
25.
Do we just add 25?
No.
What is the first thing to do? We still need to check if it is full because you don't know if it is full or not. Is it full? No. What do? We add 25. What is the next thing? Check if it is full and add 0. What is the next thing? Check if it is full and add -1. Check if it is full and add 3. Check if it is full and add 5. Check if it is full and add 7. Can you add again? No. You cannot add again. It is now full. Now, this is the problem. You were checking if it is full because you can visualize, isn't it? You can see it. You can visualize. What if it was abstract? How do you check if it is full? That is number 1. Number 2, do you guys know the first element, guys?
Yes.
What is the first element that was added?
5.
What was the last element?
7.
How do you identify the first element if you cannot see it? If you cannot visualize it? So that means to visualize the first element or to know if it is full or not, you need at least one pointer. You need what? You need pointers. You need what? Pointers. Don't let me say a pointer. You need pointers. So the pointer will point for you. So you use the pointer to track if it is full or not. You use the pointer to track the first or the last element. So that is the use of those pointers, because the reason why we are not using, the reason why we could add successfully was because we could visualize it, isn't it? If we cannot visualize it, then how do we know something we could not visualize? Is that understood? So that is the reason you need pointers to make reference to the memory location. To make what? To the memory location. For Q, I will tell you 2 pointers, but you don't have to memorize them. A question can give you 3 pointers, as the case may be. The first pointer I will tell you guys that I will use in this illustration is the head pointer. What do I call it? The head pointer. The head pointer points to the first element in the queue. That is my definition. Points to the first element. Points to the first element. Why do you need to point to the first element? What do I say is a queue? First in, first out. If you don't point to the first element, how do you know the element to take out first? Is that understood? That is the reason why it is important and compulsory to have a pointer that makes reference to the first element. And what will it point to? It will only point to the what? To the memory location of that element. Is that understood? Good. So the next pointer we need for this explanation is the tail pointer. What do I call it?
Tail pointer.
For my definition of this analysis, the tail pointer points to the next available space. To the what? Next available space. That is my definition. Another definition may say the tail pointer points to the last element. So you don't have to memorize anything. You have to understand the question. The question will define the head pointer and the tail pointer. So you write your code according to the definition of the question. So for my own illustration, this is my definition. I'll write a code for this. When I'm done, I'll give an assignment for defining tail pointer to point to the last element. So I'll give an assignment on that. Okay, good. So let's move forward. Now, let me start again by adding values to these memory spaces. Now, we are now adding values to it like the abstract, like something we cannot visualize. Is that understood? Now, is there any value in this memory location? Does this memory space have any value? No. Is it full?
No.
If it has no value, how do I define head pointer? Points to the first element. Now, let's assume that this is index, the memory address. This is index 0, 1, 2, 3, 4, 5, 6. These are the index. Since there is no value, then I need to initialize the head pointer to be equal to -1. Why did I take -1? Because -1 is not a valid index in this illustration. Is that understood? If -1 was a valid index, then I cannot choose -1. Is that understood? If I make this reference to be 1, 2, 3, 4, 5, 6, 7, then I can initialize head pointer as what? As 0, because 0 is not a valid memory index. Is that understood? Is that understood? Now, good. So, what is the first thing we have to do before we add the value? We check if it is full. So, that is the algorithm. The first thing in the algorithm is 1, check if full. Okay. Now, what do I say the tail pointer does? It points to the next available space. So, as we speak right now, what do you think will be the value for the tail pointer? It should be 1. Because the next available space is this, isn't it? Is that understood? So, tail pointer is supposed to be equal to 1. While head pointer is supposed to be equal to what? 0. Is this understood? Is this understood, everyone? Good. Now, how do you know if it is full or not? What pointer do we use to check if it is full or not? The tail pointer. Then, what will be the value of the tail pointer when it is full? If the tail pointer is 7, is it full? No. Is that understood? No. Because tail pointer is the next available space. That means wherever the tail pointer is pointing to, that means that space is available. Is that understood? If tail pointer is now equal to 8 or more than 7, what does that imply? It is now full. Because the capacity of that memory is what? Is 7. Is that understood? So the first thing, you check if what? If full. That is the first step. If it is not full, what do we do, everyone? We add the first value, isn't it? We add the first value. We add the value. So what do we add now? 5. We add 5. When adding 5, then we must make sure the head pointer is now pointing to that memory location to prove or to show to us that that is the first value. Is that understood? So head pointer, will it still be 0 now? It will be equal to what? 1. And tail pointer will be equal to what? 2. Because initially this was tail pointer, right? Tail pointer will now be equal to 2. Is this understood? Is this understood, everyone? Now, what are we adding next? What is the first thing to do? Check if it is full. Is it full? How do you know it is not full? Is it because you can see it? How do you know? Because the tail pointer is not more than 7. Is that understood? Now, what do we do? And where do we add 25 to? to the index of the tail pointer. God bless you. To the index of the tail pointer. So we add 25 to what? To the index of tail pointer. Is that understood? What do we now do now? We shift what? The tail pointer to what? Do we shift the head pointer? Why don't we shift the head pointer? Because head pointer should point to the what? To the first index or the first value. The index of the first value. Is that understood? Understood, everyone? Now, when we want to add 0, what is the first thing to do? Check if it is full. If it is not full, is it full? Then what do? We add 0 to what? To the position of what? Of the tail pointer. Then we do what? We increment the tail pointer to what? To the next available space. Is that understood? We continue to do it until we add -1, until we add 3, 5, and 7. So the tail pointer will now be equal to what, everyone? Will now be equal to 8, the next available space. Because let me go back to before we add 7. Before we add 7. Now, this should be the tail pointer, isn't it? Yeah. Tail pointer is equal to what? Is equal to 7. Now we want to add this value 7. Is this space full? No. What do? We add 7. After adding 7, what do? We increment the tail pointer. So tail pointer will now be equal to what? Will now be equal to 8. Is that understood? Now we want to add 11. What's the first thing to do? Check if it is full. Is it full? Because the tail pointer is what? More than 7. Now, can we add 11? No. 11 cannot be added. Is this understood, everyone? Good. So this process is called NQ. What do I call it? NQ. So when you try to add to a queue, is that understood? When you're adding elements to a queue. Now, if you do understand this, you should be able to write an algorithm to NQ. Yes or yes? Yeah. Yes. I have just explained the algorithm. So now you have just 3 minutes to write the Python code to a queue. But before you write, before you write, you will follow this example. Or let me say this question. So this is the question. An array is used to implement a queue with a space for 10 elements. So because we cannot visualize the memory location, so the only way we can visualize it is using what? An array. But that array is not the queue. Is that understood? Yeah. It's not the memory location. Because an array, you can have as much space in an array, isn't it? Yes. Is that understood? But we are not, so the array is not the memory location, but we are implementing it in what? In an array. Is that understood, everyone? And if you look at this, it's like an array, isn't it? So we are using an array to implement this. So the question states, an array is used to implement a queue with a space for 10 elements. The head pointer points to the first element in the queue, while the tail pointer points to the next available space in the queue. Write a main program code to declare 2 global variables, head pointer and tail pointer, and a global array, Q array, with a space for 10 integer values. Initialize head pointer and tail pointer as -1 and 0. Initialize each element in the array to what? To -1. Now, a function NQ takes an integer value as a parameter, checks if the queue is full, returns a suitable message if full, adds the value to the queue, that means if it is not full, and update the relevant pointer. Do you understand what we mean by update the relevant pointer? Good. Write program code for NQ. So 5 minutes, solve this, everyone. An array is used to implement a queue with a space for what? 10 elements. The head pointer points to the first element in the queue, while the tail pointer points to the next available space in the queue. Write a main program. So let's write the main program. df main, isn't it? I advise you to always write it as a function, isn't it? Now, write a main program to do what? To declare head pointer and tail pointer as a what? Global variable. So global head pointer. What is the declaration? Integer, isn't it? And what? Global tail pointer. What is that? Integer. Are you all following me? Okay, good. And the what? Global array, Q array, isn't it? I also have global Q array with a what? Space for what? 10 integer values. So that means an array for 10 integer values. Understood? Okay, good. What does it now say? Is that all? Initialize head pointer as what? -1. Tail pointer as what? 0. So that means head pointer is equal to -1 and tail pointer is equal to what? 0. Isn't it? Okay, good. Initialize each element in the array to what? -1. So each of the elements in the array make it -1. So you can just write Q array is equal to -1 times 10. Simple. You can also use a for loop this way. You can also write for num in range of what? 10, isn't it? Then write what? Q array dot append -1. They are both the same. Is that understood? Okay, good. Any one you write is the same thing. Just write one that is correct. Then the next question is states a function NQ. So we have another function df and q. Takes what? An integer value as a what? Parameter. So we have value as a parameter. Are you all following me? Takes an integer value as a parameter. Checks if the queue is what? Full. How do you check if the queue is full? The tail pointer. So that is if tail pointer is what? Greater than 10. Simple. Just greater than 10. Why is it greater than 10? The question already told you that there are what? There are 10 space in the queue. The queue only has 10 space for what? Only has space for 10 elements, isn't it? Simple. Just greater than 10. Understood? Good. Oh, thank you. Because the array starts as index 0, isn't it? So it should be greater than 9 and not greater than 10. Or I can write greater than or equal to 10 as well. Equal to 10 is also fine. Okay. Can you use greater than length of array? No, because length of array is 10. Can you use greater than length of array? No. But can you use greater than or equal to less than array? Yes. Okay, good. If it's greater than 9, what does that mean? Return the what? The queue is full. Is that understood? How many values are we asking? One value. Do you need to use a for loop for this? No. Why? We are adding only one value. It's as simple as that. So else means if there is space available, right? What was the first thing I told you there is space available? You add that value to this index of what? Of the tail pointer, isn't it? Is that understood? You add the value to the index of what? Of the tail pointer, because the tail pointer is the next available space, isn't it? So you now add, that will be q array tail pointer, isn't it? Is equal to what? Is equal to value. Is this understood, everyone? And don't forget, we cannot use dot append because the array already has values initialized in it. If the array does not have values initialized, then we can use append. But the array has values initialized in it, then you cannot use append. Because if you use append, it's going to append it to the end, not to the beginning. Is that understood? Good. After doing this, okay, after appending the value to the next available space, what do? You update what? The tail pointer, isn't it? Then you write tail pointer is equal to what? Tail pointer plus 1. And don't forget these global variables. You need to what? You need to put it in your function. Is that understood? Put it in your function. Now, after doing this, is this all? No, this is not all. One thing you need to know that I told you, head pointer is used for something to identify the first element or to point to the index of the first element. That means you need to make the head pointer point to the index of the first element. The head pointer was initialized as what? As -1. That means it is pointing to no element in the array. Is that understood? Because the array has no valid index -1. Is this understood? Now, have you added a value? Yes. Now that you don't add a value, what are you supposed to do? Make the head pointer point to the first value. Is that understood? So that means you need to include that if the head pointer is equal to -1, that means there was no value initially. It was initially empty. Is that understood? Then make what? Head pointer to be equal to 0, and that is all. Is this understood, everyone?